11.10, the fundamental principle of counting. Learning intention. We are learning to use the fundamental principle of counting to find a number of possible outcomes in multi-step situations. Success criteria. I can identify the number of choices at each step. I can multiply the choices together using total outcomes equals first step multiplied by second step multiplied by ... I can use boxes to organize my work and explain my method clearly. I can apply this to exam-style problems such as teams and codes. So probability is a top priority topic because full probability question appears every year on paper 2, making it very reliable for marks. Many questions use diagrams, sample spaces, Venn diagrams, tree diagrams, which means clear method marks are available even if the final answer isn't perfect. Tree diagrams in particular are often worth a large number of marks, so being confident with them can quickly boost a student's overall score. The fundamental principle of counting. This is a high priority topic, so 3 stars. It comes up most years on paper 2. It's used to find the total number of possible outcomes in multi-step situations such as teams, outfits, routes, passwords, codes, and selections. Questions can often be phrased using how many different ways, how many possible combinations, or total number of outcomes, and may appear before a probability is calculated. Easy method marks. Students who clearly identify choices at each step and multiply them correctly, often using boxes or stages, usually pick up marks even if later probability work is weak. The fundamental principle of counting. The make of car comes in 4 different models as shown below. So we've got standard S, classic C, elegant E, and diamond D. Each model comes in 3 different colors: silver S, red or black B. Here are the choices a customer has. So SS is standard silver, SR is standard red, SB standard black, CS classic silver, CR classic red, CB classic black, ES elegant silver, ER elegant red, EB elegant black, DS diamond silver, DR diamond red, and DB diamond black. So if we count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 choices listed. So for each of the 4 models, there are 3 colors. The number of choices is found by multiplying the number of models by the number of colors, i.e. that is 4 times 3 is 12. So this example illustrates the fundamental principle of counting, which is given on the right. If one task can be done in X ways and following this a second task can be done in Y ways, then the first task followed by the second task can be done in X multiplied by Y ways. Example 1. A team consists of 11 players. In how many ways can a captain and a vice captain be chosen? So for the captain and the vice captain, there's only going to be one person in each of those places. That's why I've put one box below each of the words. So when we hear the phrase how many ways, we want to think multiply. So how many, you want to think multiply. So we're going to multiply our number of options for the captain by our number of options for the vice captain. So there's 11 players, so we've got 11 people to choose from for the captain. So we put 11 into the first box. And if one person has been chosen as captain, then we've only 10 people left to choose from for the vice captain. So if someone gets chosen as captain, then there are only 10 people left to choose from for the vice captain. So we have 10 options for vice captain, so 10 goes in this box. And 11 times 10 is 110 ways. So there's 110 different ways that we could choose a captain and a vice captain from a team of 11 players. So there are 110 ways to choose captain and vice captain. When dealing with 2 or more operations, it can be convenient to use boxes for the selection as shown on the right. So first times second times third and so on. Example 2. A code consists of a letter of the alphabet followed by 2 different digits from 1 to 9 inclusive. How many codes are possible? So a letter of the alphabet, well, there's 26 letters in the alphabet. And there are 9 digits from 1 to 9 inclusive. So we have a letter, and then a digit, and then another digit. So this is our code. So it's got 3 symbols in it. So we've got a letter, then a digit, and a digit. So a letter and a digit and a digit. So when we see the phrase how many, we want to think multiply. And in probability, and means multiply. So we're going to stick multiplication symbols in here. So there's 26 letters in the alphabet. So in our first box, we've got 26 letters to choose from. And then for our digits, we've got 9 digits to choose from. So 9 goes in that box, highlighted in yellow. And it tells us specifically that the digits have to be different. So we can't repeat a digit. So if we've used one of the digits already here, it doesn't matter what it is, we've only got 8 to choose from for the final box. So after the first digit is chosen, there are only 8 digits left to choose from. So we're going to put 8 in this box, and 26 times 9 times 8 gives us 1,872 different codes that we could come up with. So there are 1,872 codes possible. Example 3. A committee consists of 10 people. In how many ways can a chairperson and a secretary be chosen? So we've got a chairperson and a secretary. So we've got one box for the chairperson and one box for the secretary. In how many ways, we want to think multiply. So it's chairperson and secretary, and means multiply. So in how many ways, we multiply. So we have 10 people to choose from for the chairperson. So 10 goes in the first box. And if one of them has already been chosen, we've only got 9 people left to choose from for the secretary. So if one person is chosen as chairperson, then there are 9 people left to choose from for secretary. So 9 goes in the second box. And 10 times 9 is 90. There are 90 ways to choose the chairperson and the secretary. Example 4. How many different 3-digit numbers can be formed from the digits 4, 5, 6, 7, 8, 9 if each digit is used once only in a number? So we're going to have a digit, and then another digit, and then another digit. So it's a 3-digit number we're creating. So we have 3 boxes. So we'd see the phrase how many, so we think multiply. So we're going to have a digit and a digit and a digit, and means multiplying probability. So from the numbers 4, 5, 6, 7, 8, and 9, there are 6 digits to choose from for the first digit. So 6 goes in the first box. And if we've used one of them, it doesn't matter which one. Once we've used one of them, we've only got 5 digits to choose from for the second digit. So after the first digit is chosen, there are 5 left to choose from for the second digit. So we have 5 options for the second box. And likewise, once we've used the first and the second digit, whatever they are, we've only then got 4 digits left to choose from for the last box. So after the first and second digits are chosen, there are 4 left to choose from for the last digit. So 4 goes into that last box. And 6 times 5 times 4 gives us 120 different 3-digit numbers we can form. So there are 120 ways to form 3-digit numbers. Example 5. There are 8 horses in a race. In how many ways can the first 3 places be filled? So we've got first place, second place, third place. So we've got 3 boxes. So in how many ways, we want to think multiply. So it's going to be first place and second place and third place. And means multiplying probability. So for the first box, there's 8 horses that could possibly come in first place. So 8 goes in the very first box. Once the first horse is across the finish line, there's 7 horses left that could possibly get second place. So after the first place horse finishes, there are 7 horses left for the second place. And then likewise, after the first place and second place horse has crossed the finish line, there's then going to be 8 minus 2 which leaves us with 6 horses left that could possibly get the third place. So after the second place horse finishes, there are 6 horses left for the third place. So 6 goes in our last box. And 8 times 7 times 6 gives us 336. Therefore, there are 336 ways for the first 3 places to be filled.